Hello again. In our last lecture, we talked about the common criteria. That's a set of evaluation criteria for secure systems. And we said there were two things that you could evaluate. You could evaluate protection profiles, which are actually policies or models of security for particular kinds of systems. And you could also evaluate products, specific systems that people had built. Let's talk about a protection profile today to see what one of those looks like. Well, this is kind of an idiosyncratic example, but an interesting one. It's called the German waste bin identification system. And the idea, you wouldn't think of this ordinarily as a secure system, but it has some security aspect. So what's the idea? So someone wants to implement a system where you can embed identification tags in waste bins, trash cans, and then when the truck comes along and empties them, it weighs the bin and then collects that information, and so someone is charged on the basis of how much trash they've thrown away by weight. Okay, so what's the threat model? Well, someone might try to subvert this system. The information is being transmitted from the ID tag to the truck via shortwave, and so somebody might, for example, broadcast a faulty signal, or they might try to destroy the ID tag, or something else. Okay, so the way this works in a protection profile is you're supposed to identify the various threats, the various system assumptions, the security objectives, what you want to accomplish. First thing to ask is always what are the assets? Well, it's basically these records which are being recorded by the truck, and the record contains the bin ID, the timestamp when this was recorded, and also the weight. And then the accounting information is computed on the basis of that, and so someone is billed for the amount of trash they threw away. So you have certain environmental assumptions. There should be an ID in each waste bin. The crew in the truck should be trustworthy, so they're not trying to subvert the system. There's certain access control so that an arbitrary person can't go in and change their records, for example. The operator should check at certain intervals to make sure that the data is actually being recorded and is being fully recorded before the truck drives away, for example. And then there's some backup, right? Okay, and then what are the threats? Well, whoever put this together identified at least 4 threats. Someone smashes the tag. The attacker sends a signal to corrupt the data being read by the truck, or the attacker corrupts the data somehow during the processing and storage within the truck, or then there's some failure in, or the attacker creates and broadcasts arbitrary data. So those are threats that one might imagine. Have they thought of all threats? Well, we're not sure, but it seems like that's a pretty good enumeration. And then finally, there's something called an organizational security policy, which says that the system has sufficient backup mechanisms, so there's fault tolerance built into the system. Okay, so then what are the security objectives that we would like to accomplish? Well, 3 of them are listed here. We want to be able to detect an invalid or inoperable ID tag. We want to detect invalid bin clearing messages. So for example, if someone broadcasts via shortwave a spurious message, and we want to have certain fault tolerance in the system. Now remember that what's being described here, since this is a protection profile and not a security target, that this is just the definition of security for a class of systems, these bin clearing systems. It's not a particular product that someone has implemented. One might imagine that they'll come along later and actually sell a product, but this isn't it. This is the description of security for this class of products. And so you're not saying what particular mechanisms are in a particular system because there isn't one. You're saying what general classes of mechanisms you need to worry about for systems of this type. And so the security requirements here are broad security requirements: data authentication, internal transfer integrity protection, and stored data integrity. Now, since these are general classes of security requirements rather than particular mechanisms, what they do is specify certain sections of the common criteria documents which describe what these things are. So for example, basic data authentication is described in a section, and the numbers listed there. And I've quoted a little bit of it here for you. The idea is that we're not saying, or the writer of this protection profile is not saying how they're going to implement this. They're just saying what needs to be implemented, in particular basic data authentication. And the reason they reference this section from the documentation is that this tells anyone who's going to implement this system what are legitimate ways of accomplishing this. So for example, cryptographic checksums, fingerprints, message digests, those are all ways that one might look at to get basic data authentication. And the idea here is that if you come up with a different mechanism, then you're going to have to argue that that mechanism actually accomplishes this. But if you use any of these standard mechanisms, then the community has already said, well, these are legitimate ways to accomplish this goal of basic data authentication. And so you don't have to work nearly as hard. Okay, so after we've done all this work of identifying, threats, assumptions, security requirements, and things like that, then you build this matrix. And on the left are the threats and the assumptions, and across the top are the security objectives and the system requirements for any system that's actually built. The idea is that if you fill in this matrix with a security objective or requirement designed to counter a threat or fulfill an objective, and every row in this table has an X in it somewhere, then you know that you've thought about this carefully enough such that all of the threats actually have some corresponding mechanism to counter them, and all of the assumptions actually have some mechanism within the system which validates the assumption. And so this gives you a systematic way of determining whether the mechanisms that you're proposing are adequate to solve the problems that are presented. Okay, so what have we said? Well, this German waste bin identification system is an example of a protection profile, a pretty peculiar example, but nevertheless it illustrates the basic form of one of these things. Notice that it doesn't relate to any specific product, but rather it describes the security mechanisms which you might put in place for any such product. And it also provides a systematic way of deciding whether the threats and the assumptions which a system like this might encounter are being addressed by the mechanisms and the requirements that you would impose. Thanks.